Hello friends, welcome back to the section. This section is part 3, Measures of Dispersion. I am Dr. N.V. Ravi. I am mentor for this session. Now we are going to discuss on mean deviation, which is part 3 of the Measures of Dispersion. Now the mean deviation regarding, since range is based on only two observations, it is not regarded as an ideal measure of dispersion. A better measure of dispersion is provided by mean deviation, which, unlike range, is based on all the observations. For a given set of observations, mean deviation is defined as the arithmetic mean of the absolute deviation of the observation from an appropriate measure of central tendency. Hence, a variable x assumes n values x1, x2, etc. xn values. The mean deviation of x about an average A is given by mean deviation from mean or average is given by 1 by n of the absolute value of summation of xi minus observations deviation from mean. For a grouped frequency distribution, mean deviation from average can be written as 1 by n of summation of xi minus A is the average or x bar into respective frequencies, which is the for the grouped frequency data, where xi and fi denote the mid values of the frequency and ith frequency class, and n equal to summation of fi. Now, in most cases, we take the mean or median accordingly, but we get mean deviation about mean or mean deviation about median. Even some cases, we use in the place of average as median also. A relative measure of dispersion applying in mean deviation is given by, that is, coefficient of mean deviation equal to from mean deviation about average mean deviation about average by respective mean into 100. In the case of coefficient of mean deviation from median is mean deviation about median by median into 100. Mean deviation takes its minimum values when the deviations are taken from median. This is the very important for the MCQ point of view also. Mean deviations takes its minimum values when deviations are taken from median. This is the important property related to mean deviation also. Also, mean deviation remains unchanged due to change of origin, but changes in the same ratio due to change in the scale. This is applicable to other measures of dispersion like range, quartile deviation, mean deviation, and standard deviation also. Here also the mean deviation, suppose y equal to a plus bx is the linear equation where a and b are constant. A is called the origin, b is called the scale. Here also mean deviation of y when x is known, mean deviation of x is known, which is absolute value of modulus of b, that is modulus of b into mean deviation of x. These are the important properties related to mean deviation. Let us come to the questions part related to mean deviation. If the quartile deviation of x is 6 and the linear equation is 3x plus 6y equal to 20, what is the quartile deviation of y? Now let us look at the equation, that is 3x plus 6y equal to 20. From this, 6y equal to 20 minus 3x and y equal to 20 by 6 and plus of minus 3 by 6 into x. Now we want to find the quartile deviation of y, and that is quartile deviation of y is this b coefficient, that is minus 3 by 6 into quartile deviation of x is given is 6. So the 6 gets cancelled. We can take only absolute value, that is positive value, 3 is, that is 3. So quartile deviation of y is 3. Now question number 2. From the following data, marks of the 10 students are 56, 48, 65, 35, 42, 75, 82, 65, 55 and 50. Find the quartile deviation and also its coefficient. Now we have to find out the first quartile, third quartile, after that quartile deviation and coefficient of quartile deviation also. Before finding the quartiles, first we arrange the data into ascending order magnitude. After arranging the ascending order magnitude, we get the data as follows. That is 35, 42, 48, 50, 55, 56, 60, 65, 75 and 82. Now the first quartile Q1 equal to n plus 1 by 4th item, and this is 10 plus 1 by 4th observation or item. This is 2.75 item. Now that is can be second observation plus 0.75 into difference between third and second item. Difference between third and second item. Now let us look at the data. The second item is the 42 and plus 0.75 into difference between second and third item is 48 minus 42nd, which is equal to 46.50 is the first quartile deviation. Now coming to the third quartile, the third quartile computation is as follows. 3 into n plus 1 by 4th item, that is equal to 3 into 2.75, that is 8.25 item. Now 8th item is 65 plus 0.25 of 9th, difference between 9th and 8th item, that is 65 plus 0.5 into 10, this is 67.50. Third quartile is 67.50. Now we have to find the quartile deviation. Quartile deviation equal to Q3 minus Q1 by 2. This is 67.50 minus 46.50 by 2, which is equal to 10.50. Now quotient of quartile deviation. Important formula, students has to remember this. This is the quartile deviation. This is the next one is quotient of quartile deviation, Q3 minus Q1 by Q3 plus Q1 into 100. After substituting the values of Q3 and Q1, 67.50 minus 46.50 by 67.50 plus 46.50 into 100, which is equal to 18.42 in percentages. This is the quotient of quartile deviation. In this, you have to remember this formula, very important. And quartile deviation is Q3 minus Q1 by 2. Let us come to the question number 3. The mean and variance of 5 observations are 4.80 and 6.16 respectively. If the 3 observations are 2, 3 and 6, what are the remaining observations? Now let us come to the question once again. Here the mean and variance of 5 observations are, first mean is 4.80 and variance is 6.16. If 3 observations are 2, 3 and 6, what are the remaining observations? Now see the solution as follows. Let the remaining observations, we have to assume that A and B, these are the remaining observations. Now we have to find the, based on the data, the mean is here given. Mean is sum of the observations by number of observations. That is, 3 observations are given, 2 plus 3 plus 6 plus A plus B, the other 2 observations. We assume that by 5 equal to 4.80 and 2, 6 plus 3, 9, 9 plus 2, 11. 11 plus A plus B equal to 4.80 and implies A plus B equal to 13. A plus B equal to 13. In the earlier side, based on the data, we got the A plus B value is 30. We assume that this equation is 1. And based on the variance also, that is formula 2 square plus A square plus B square plus 3 square plus 6 square by 5 observations minus mean square. Mean is 4.80 whole square, which is equal to 6.16 as per the data. Now all this sum is equal to 49. 49 plus A square plus B square by 5 minus 23.04, which is equal to 6.16. Now after simplification, this will be equal to 49 plus A square plus B square equal to 146, implies A square plus B square equal to 97. This is the, we assume that second equation. Now from first equation, A plus B equal to 13, then implies, using the first equation, A plus B equal to 30. From this, A equal to 13 minus B. If you substitute this A in the place of A square here, that is 13 minus B square plus B square, which is equal to 97, and which is in the form of the quadratic equation, that is but 169 minus 26B plus 2B square equal to 97. Then after simplification, which is equal to B square minus 13B plus 36 equal to 0. And 9 4s are 36. Simply, this is B minus 4 into B minus 9 equal to 0. From this, B equal to 4 or 9. And from this equation, this is, we are assuming that third equation. If you substitute 4, this will be A equal to 9. If you substitute 9 it will be 4. So vice versa. So thus observations are 4 and 9 for the A and B equations. Now let us look at the question number 4. After shift of origin and scale, a frequency distribution of a continuous variable with equal class length takes the following form of the changed variables D. D is -2, -1, 0, 1, 2. Frequency is 17, 35, 28, 15 and 5. If the mean and standard deviation of the original frequency distribution are 54.12 and 2.1784 respectively, find the original and frequency distribution. Now we have to find the table for this data. We need to find out the origin A and scale C from the given conditions. Since di equal to xi minus A by C, from this xi equal to A plus C di. Once A and C are unknown, the mid values xi's would be known. Finally, we convert the mid values to the corresponding class boundaries by using the formulae. LCB equal to xi minus C by 2 and UCB is xi plus C by 2. On the basis of the given data, we found sigma fi di equal to -44 and sigma fi di square is 138 and n equal to 100. The sum of the observations frequencies. On the basis of the given data, we found that sigma fi di is -44 and sigma fi di square is 138, n is 100. Here S is standard deviation, sample standard deviation, and formula is sigma fi di square by n minus sigma fi di square di by n whole square into C. This is sample standard deviation is 2.1784 and this is 138 given, found after the simplifying the data, after the data adding, and minus 138 by 100 minus this is minus of 44 by 100 whole square. We need to find the C value, length of the class interval, and this is 2.1784. This is 1.38 plus minus of minus square is minus plus, but here minus only. This is minus 0.1936 into C. From this 2.1784, which is equal to the square root of all the different value 1.0892 into C. From this C value is, by dividing these two, this by this, which is equal to C equal to 2. So length of class interval is 2. Now further, x bar equal to, this is given, this is based on the standard deviation value. This is, now we have to find the based on the mean value. Mean equal to A assumed arithmetic mean plus sigma fi di by n into C. N into C is 100. Okay, this is in the place of that C. Sir, C is, we didn't find anything. C is 2 and this is 100 is sum of the frequencies, and mean is 54.12 and A is as it is, we have to find out, and this is 44 by 100 into 2, and which is A minus 0.88, which is equal to A equal to 54.18 plus 0.88, A equal to 55. Thus, xi equal to A plus C into di, xi equal to 55 plus C is class interval is 2, and di values we have given that -2, -1, 0, 1, 2. After substituting these values, we can find the respective class xi values. See, look at these values in the next slide. Now let us look at the computation of the original frequency table as follows. This is the computation of table. Now DI values are -2, -1, 0, 1, 2, and respective frequencies are 17, 35, 28, 15, and 5. Now xi equal to 55 plus 2 di, and a class interval is xi plus or minus c by 2. Okay. Now we have to find out this is the generally giving in the xi values. Based on the xi values, we have to find the class interval x. This is 55 plus 2 di is 51, 53, 55, 57, and 59. Di value already earlier slide we have found that di value also. Now this c value is 2, so xi plus or minus 2 is 52, 52, 52, 54, 54, 56, 56, 58, 58, 60. If we look at the earlier slide, we have found that C value is 2, 2 by 2 is 1, so 51 minus 1, that is 50, and 51 plus 1, that is 52. This is minimum and maximum values. Like this way, based on the C value, if you add all the things, then 52, 54, 54, 56, 54, 58, the length of the class interval is 2. So this is the way to find out the table based on the data. Now let us look at the question number 5. Compute the quotient of variation from the following data. Here age under 10, under 20, under 30, under 40, under 50, and under 60 are given. Respective number of person dying is 10, 18, 30, 45, 60, and 80. What was the problem given in the less than cumulative frequency distribution case? Here all these cases are less than cumulative frequency case. We need to first convert the frequency distribution and then compute the coefficient of variation. You all know the coefficient of variation equal to standard deviation by mean into 100. Now this is the case of the less than cumulative frequency distribution. Now we have to convert this data into frequency distribution test. Then how? Look at this. Before that, this under 10 is 18, under 20 is 18, 18 minus 10, and 30 minus 18, this is less than that. We have to subtract like this way, and 45 minus 30, and 60 minus 45, and 80 minus 60. The total is 80 people like. Now in the next table, next slide, we can look at the table, how to compute it. Now this is the data can be computed as follows. One is 0 to 10, 10 to 20, 20 to 30, 20 to 30, 30 to 40, and 40 to 50, 50 to 60 and total. And number of persons, first one is 10, second one is 18 minus 10, which is 8, 30 minus 18, which is 12, and 45 minus 30, which is 15, and 60 minus 45, which is 15, and 80 minus 60, which is 20, and the total is 80. Now mid values is lower upper boundary plus lower value plus upper boundary by 2, that is 5, and the length of the class interval is 10. If you add 10 to each, 15, 25, 35, 45, and 55. This place is blank. And di is, we assume that this 25 is the assumed mean, which is 0. Yeah, the formula is xi minus a by c. Now a is 25, c is the length of the class interval is 10. So this is minus 1, this is minus 2, this is 1, 2, 3. And 10, this value is minus 20, and this is 8 into minus 8, 0, 15, 30, 60. Sum of these values is 77, and dA square into Fy, this is 40, 8, 0, 15, 60, 180. The sum of these values is 303. In the next slide, the arithmetic mean is computed as follows. Arithmetic mean H is x bar equal to A plus summation of Fi di by n into C, which is A is assumed is 25, Fi di value is 77, by sum of the values is n is 80 and class interval is 10 differential, which is equal to 34.63. S is the average. Now the standard deviation S equal to square root of summation of Fi di square by n brackets summation of Fi di by n whole square into C, which is 303 by 80, 77 by 80 whole square into 10, which is equal to 3.79 minus 0.93 into 10, which is equal to 16.91. Now the CV we have to find coefficient of variation. This is standard deviation by mean into 100, which is equal to 16.91 by 34.63 into 100, which is equal to 48.83. This is the coefficient of variation for this data. Now with this I complete the topics on the quartile deviation. Now we have discussed about the various measures of dispersions also. We may note that range is the quickest measure of computing the quartile deviation. Range is the quickest measure of computing the measures of dispersion. It has used in the statistical quality control. However, range is based on the only two observation and affected by too much of the presence of extreme observations. Mean deviation is rigidly defined based on all the observations and not much affected by the sampling fluctuation. However, mean deviation is difficult to comprehend and its computation is also time consuming and laborious. Furthermore, unlike standard deviation, mean deviation does not process the mathematical property. Mean deviation does not proper mathematical properties because it has taken all the negative values also considering the positive values. So it has the difficulty in the computing. Quartile deviation is also rigidly defined, easy to compute, and not much affected by the sampling fluctuation. The presence of examination has no impact on the quartile deviation, since the quartile deviation is based on the central 50% of the observation. However, the quartile deviation is not based on all the observation. It has no desirable mathematical property. Nevertheless, the quartile deviation is best measure of dispersion for open-ended classification. Students, you have to remember about the quartile deviation when computing, in the examination point of view also. Quartile deviation is the best measure of dispersion for open-end classification. With this, I conclude the section on the measures of dispersion. Thank you very much. Wish you all the best.